So today we will be reviewing functions, and we'll start on inequalities and inequality symbols. Our main objective will be to use a number line to graph the solution. The order may switch on how we'll do this today, but essentially we will be going over different ways of functions, doing a quizzy on functions, taking a break after the quiz. Then we'll do some more inequality work. We'll watch a video on inequalities. And then this is where I do want to help everyone log on to IXL. So maybe we'll do this for the last 10 minutes of class. I do want to take a screenshot of classwork so I can use it to just get participation points for the day. Asynchronous is getting onto that IXL.com. And you just want to get a SMART score of 80 on at least 3 skills above the 6th grade level. So this is your warm-up. We'll give you a table. I'm sure you know how to use tables. Just treat it like a machine. It has 4 buttons, A, B, C, D, and then 2 number buttons, 1, 2. If you want to buy some sort of juice, you'll have to use a combination. And you'll just answer which output corresponds to D1, banana, which output corresponds to C2, grape, and which output has apple juice. And you just go ahead and circle as a warm-up. I'll go over the general updates and rules. Mr. Ellis wants us to go over these every class. Different ways to represent a function. So this is an example of a function. If you put in an input, you get exactly 1 output. And so we can write it as a table. And so tables are one way we can represent functions as input, A1 equals a certain output. We can also do mapping. So if these were numbers, every input would have exactly 1 output. Or graphs, where you take x values, this line's your input, and there should only be 1 point on each value of the x, and we can generally, every function has exactly 1 input and output. That's what makes it a function. And so you can kind of see this was our table. If I put in A2, I'm never going to get cranberry, I'm not going to get orange, I'm going to get raspberry all the time. That is what I mean by inputs, and we can switch this numerically. Same thing, if I put in A2, I'll always get cranberry. I can never get nothing else. If it goes to somewhere else, that means the machine's broken. It's not a function. Same thing with B2, B1. They all go to exactly 1 output. So I just want you to go ahead and just try out exactly what you just seen. See if you can't fill in this table. You can put in any input or output. Just make sure it corresponds. For example, if I do A1, I know that this has to be raspberry. And I can't write it all out unless I use the function, but I can just put raspberry. And so you would go ahead and fill this out, show me that you know what it means to be a table, or not know what it means to be a table. This will be a little review on that. Another thing is mappings. All tables have a map too that you can write as a function, but remember, when we do mappings, every input has to have exactly 1 output. So you can kind of see here, if you put in 1, you get 4. Same thing with a mapping. If you put in an input, it has to go directly to its output. You draw a little arrow. 2 goes to 3, and 6 goes to 5. And so mapping's really straightforward. You can just imagine that's a table without the table. And so then I would ask you to create your own mapping, just using this data that I've given you. Go ahead on your, and I'll be using digitalwhiteboard.fee.com for whiteboards that you guys can use. And then just if this is a function, remember every input has to have exactly 1 output. I would have you guys type it in the chat box. So now some of these don't even have any outputs. A few of them have multiple outputs. That's not a function. And then little table, what ordered pair would prevent this from being a function? Again, we don't want things to have matching, so it can't be a function with like a -3, a -2, a 0, or a 5. And if we look over here, there is one option that has -2 on it. And so that would mean that, oops, let me go ahead and go back. I appear to have done something. Okay, so while this is happening, let's see, so I think we're on, not that one, not that one. Here we are. I think we were right here. So click present. And so over here, if we had -2, this would mean that our input would be -2 and our output would be 0. But we already have a -2 input and its output is supposed to be 4, not 0. So that would make it not a function. Clear my drawings. Let's see. So then math doesn't have to be in numbers, it could also be in symbols. Is this a function? Go ahead and type your answer in the chat box. The answer is yes. You can have one input go to the same output, but they can only have one and exactly one output. You can also represent data in the form of a graph. So here you can kind of see that we plotted the points -3 and 0, and these are called zeros. We'll show more about this in the future. -1, 0, and -2, 0, and then over here at 4, it's like -4-ish. And so we can go ahead and draw our data as like a graph. And so when we draw our data as a graph, there is a neat test that we can do to see if it's a function, and that is if it passes the vertical line test. The vertical line test is that you just draw a straight line down and see if it intersects with the graph exactly once. If it intersects more than once, it's not a function. Here you can see intersects only once, it's a function. Again, intersects only once, and so if it passes this test, it is a function. So go ahead in the chat box. Does this pass the vertical line test? And now people will write their answer. Same here, but this one's kind of a giveaway because I went ahead and I drew the vertical line test there. And I'll just ask you, like, if this is a function, and you'd say no, it's not a function, does not pass the vertical line test. Perfect, that was it for the review. Let's go ahead and just see. Now I'm just gonna check how much of this you retained. After that, we would take a break, do a quick Nearpod video on inequalities. And so what the video would go over is like the greater than, less than, greater than, equal to symbol, less than or equal to symbol, some examples of what it looks like. You want to remember that, actually we'll go over that later, I guess. But our aim is to always have our solution on one side, so a variable all on its own. So if you're given something like x plus 2 is greater than 12, you would do the algebraic function, which is we would want to isolate x. So we would subtract 2 for equality on both sides. So that would get rid of this +2, and we get x is greater than 10. Solved. Pay attention to the sign of the direction. The way the arrow is opening up means that's the bigger number, whereas it closes down means it's a smaller number. If you change the direction, that changes the meaning. So this would be tiny, less than, but this side, if we read it left to right, is bigger, so it's greater than. This side's bigger, greater than, but now it's tiny because the sign switched, and that's less than. It can change the meaning of the word. And then for boundary value, I think we did not go over this in every class, but boundary value is just where the point of the solution is beginning, kind of like that. And so if you had to draw your solution on a number line, x equals 3, you just put a dot on 3. And same thing, if x is greater than or equal to, you use that same closed dot. However, if it does not include 3, what if you're looking for everything strictly greater than or strictly less than? Then you would use a open dot to show that you're not including that number. But you still draw the arrow to show which numbers are better or true. So for x has to be greater than, you can tell by the big symbol, we want all numbers greater than 3. If it's less than, we want all numbers less than 3. So we shade in everything below. And yeah, that's it. That's it for the day.